Have you ever wondered where the elements that make up our world, like the iron in your blood or the gold in your jewelry, come from? The answer lies in the life and death of stars, the ultimate cosmic alchemists. From their birth in swirling clouds of gas and dust to their explosive ends as supernovas, stars forge the building blocks of the universe in their fiery cores. These celestial giants don't just light up the night sky. They shape the very fabric of existence, leaving behind remnants that give rise to new stars, planets, and even life itself. Join us as we unravel the epic story of stars, their birth, their life, and their spectacular deaths, and discover how we are all connected to the stars above. In the vast expanse of the universe, where darkness is punctuated by the faint glimmer of distant suns, there exists a story older than time itself, a story of creation, destruction, and rebirth. This is the story of stars, the celestial giants that light up the cosmos and shape the very fabric of existence. From their humble beginnings in the cold, dark nurseries of nebulae to their explosive ends as supernovas, stars are the ultimate alchemists, forging the elements that make up everything we know, including ourselves. This is their tale. In the heart of a sprawling nebula, a cosmic ballad begins. These nebulae, vast clouds of gas and dust, are the cradles of star formation. They are cold and dark, but within them lies the potential for brilliance. Gravity, the silent architect of the universe, begins to pull the gas and dust together, forming dense clumps. Over millions of years, these clumps grow denser and hotter, until the pressure and temperature at their cores become so intense that nuclear fusion ignites. A star is born. This newborn star, now shining with the light of 1,000 suns, begins its life on what astronomers call the main sequence. Here, it will spend the majority of its existence, burning hydrogen into helium in its core. The energy released from this process radiates outward, counteracting the force of gravity and maintaining the star's delicate balance. But not all stars are created equal. Some are small and dim, like red dwarfs, which burn their fuel slowly and can live for trillions of years. Others are massive and luminous, like blue giants, which burn brightly but exhaust their fuel in just a few million years. Our own sun, a modest yellow dwarf, falls somewhere in between, with a lifespan of about 10 billion years. For a star, life is a constant struggle between gravity and fusion. Gravity pulls inward, trying to collapse the star, while the energy from fusion pushes outward, trying to blow it apart. This balance is what keeps a star stable for most of its life. But as a star ages, it begins to change. In its core, hydrogen is steadily converted into helium. For smaller stars like the Sun, this process is relatively slow and steady. But for massive stars, it is a race against time. These stars burn through their fuel at an astonishing rate, producing immense amounts of energy and light. As the hydrogen in the core is depleted, the star begins to evolve. For smaller stars, the core contracts and heats up, while the outer layers expand and cool, turning the star into a red giant. During this phase, the star's outer layers can extend millions of kilometers into space, engulfing any nearby planets. For massive stars, the changes are even more dramatic. As they exhaust their hydrogen, they begin to fuse heavier elements, like helium, carbon, and oxygen, in their cores. Each new stage of fusion produces less energy than the last, causing the core to contract further and heat up even more. This process continues until the star's core is filled with iron, an element that cannot be fused to release energy. When a star can no longer sustain fusion, its fate is sealed. For smaller stars like the Sun, the end is relatively peaceful. The outer layers drift away into space, forming a beautiful cloud of gas and dust called a planetary nebula. What remains is the star's core, now a white dwarf, a dense, Earth-sized object that slowly cools and fades over billions of years. But for massive stars, the end is far more spectacular. When the core of a massive star fills with iron, fusion stops and gravity takes over. The core collapses in on itself, reaching temperatures of billions of degrees. The outer layers of the star, no longer supported by the energy from fusion, come crashing down onto the core. The result is a cataclysmic explosion known as a supernova. For a brief moment, a supernova can outshine an entire galaxy, releasing more energy than the sun will in its entire lifetime. The explosion scatters the star's remains across space, enriching the surrounding region with heavy elements like gold, silver, and uranium. These elements, forged in the heart of the dying star, become the building blocks for new stars, planets, and even life itself. The death of a star is not the end of its story. The material ejected by a supernova spreads through space, mixing with the gas and dust of the interstellar medium. Over time, this material can collapse under gravity, forming new stars and planets. In this way, the death of one star gives birth to countless others. But the legacy of stars goes even deeper. The elements they produce, carbon, nitrogen, oxygen, and more, are the building blocks of life. Every atom in your body, every molecule in the air you breathe, was once part of a star. In a very real sense, we are all made of stardust. This cosmic cycle of birth, death, and rebirth has been playing out for billions of years, and it will continue for billions more. Stars are not just distant points of light in the night sky. They are the engines of creation, the architects of the universe. As we look to the future, we can see that the story of stars is far from over. New stars are being born every day in nebulae scattered throughout the galaxy. These stars will live out their lives, shaping the cosmos around them, before eventually meeting their own ends. But the universe is a dynamic place, and the fate of stars is not set in stone. Some stars will end their lives as white dwarfs, slowly cooling and fading into darkness. Others will explode as supernovas, scattering their remains across the galaxy. And some, the most massive of all, will collapse into black holes, regions of space where gravity is so strong that not even light can escape. Yet even in death, stars continue to shape the universe. The material they leave behind becomes the raw material for new stars, planets, and perhaps even new forms of life. The cycle continues, an endless dance of creation and destruction that has been playing out since the dawn of time. As we gaze up at the night sky, we are reminded of our connection to the cosmos. The stars above are not just distant suns. They are our ancestors, the source of the elements that make up our world and our bodies. In their light, we see the story of the universe, a story of birth, death, and rebirth. So the next time you look at the stars, remember, you are not just an observer of the cosmos. You are a part of it, a living testament to the incredible journey of stars. From the depths of a nebula to the heart of a supernova, the story of stars is our story, written in the language of light and time. And as long as there are stars in the sky, that story will continue, an eternal reminder of the beauty, power, and mystery of the universe.